All right, so I'm going to leave trigonometric ratios for you to review, but what I did want to do in this video is explore the unit circle, basically what we were going to do in class today. So these are kind of the major questions of the unit circle, and I'm going to just walk us through the start of the unit circle and then creating that and how it impacts trigonometry. So that being said, we start with unit circle, and unit meaning one. So in math, anytime you've seen the word unit or a unit, we're talking one. So when we say unit circle, that means we're talking about a circle with radius equal to 1. All right, so if I were to draw a radius, meaning from our center to a point on the circle, we're always going to have a distance of 1. And so what we explored in class are kind of these really important coordinates on our circle. You'll see that they're the coordinates that where our circle intersects our x and our y axis. And so if we've got a unit circle, meaning the distance is 1, then we have a value of 1. So if we're on the x-axis here, we're going to have a coordinate of 1, 0. With the unit circle, and when we're looking at degrees and angles, we typically look at the counterclockwise direction. So counterclockwise is our positive direction. Positive direction, positive angles. What that means for us is if we go the other way, so counterclockwise is positive. If we go the other way, meaning clockwise, we're going in a negative direction. Okay. All right. So let's finish these coordinates now. We're going from 1, 0, and we're moving up to this point here. And this point is going to be on the y-axis. So we get the point 0, 1. We're going to keep going over here. And we're back to the x-axis. So we're going to have the point -1, 0. And keep moving. And now we're back to the y-axis. So we have x coordinate of 0. And we're in the negative region of the y-axis. So it's going to be -1. All right. So those 4 points are the pretty classic points of the unit circle. But I want to explore what happens if we just have a point anywhere on our circle that doesn't lie on one of the axes. So what we do is we create this thing called a terminal angle. So our angle, we have this starting point here. We'll call this our starting value, starting point. And we create this angle right here. And in math world, we call that angle theta. And it's called a terminal angle because it ends at wherever this line is. And this line comes out from our center of our circle, which for us is 0, 0. And it goes to wherever our point is. Now, let's just call our point AB for the sake of just being kind of easy on us. And if we want to connect this angle and the trigonometric ratios and relationships to what we've already learned and already discovered, we're going to drop a perpendicular and create a right triangle because we've learned about right triangles. So I create this triangle here, and now we've got these established figures that we can start to answer some of these questions that I've given you on the slides. So the first one says, what is the length of the hypotenuse? So if we're looking at the bottom here, I'm going to zoom in a little. So what is the length of the hypotenuse? Well, this is a unit circle. So, and you'll notice that the hypotenuse of this angle or of this triangle is the length of the radius. So this distance here is going to be 1. So the hypotenuse has a length equal to 1. Now, what is the length of the height of our triangle? If I look at this distance from here to here it's the distance from 0 to whatever our y value is. So you'll notice that this triangle has a height of b. Okay, so the height is equal to b. And what's the length of the base? So if we go back up, the length of our base is going to be the distance from 0 to our x-coordinate, which is a. So I'm going to write that here. Our base of our triangle is equal to a. Okay, so now that we've got things established here, this kind of generic unit circle, we've got some questions here. First one dealing with cosine, second one dealing with sine, and the last one dealing with tangent. So if we think back to our acronym that we learned, SOHCAHTOA, the cosine has this acronym CA. Cosine is equal to adjacent over hypotenuse. So if I'm looking at this triangle and I want to know what's the cosine of theta, then I want to create a ratio, let's do green, that gives me adjacent over hypotenuse. All right, so the cosine of theta is equal to adjacent over hypotenuse, where our adjacent is a and our hypotenuse is 1. Well, anything divided by 1 is just itself. So I see that the cosine of theta is equal to our a value, our x value. So this right here is the cosine of theta. All right, let's go to pink for this one. So if I'm looking at sine, I go back to my acronym, SO, and I know that the sine of theta is equal to opposite over hypotenuse. So the opposite value of theta is b, and the hypotenuse is 1. So I'm going to come back down here and b over 1, which is just b. So the sine of theta is b. Well, that's just our y value. So this is going to be sine of theta. All right, last one is our tangent. So the tangent of our angle is, oops, I should put the acronym TOA, SOHCAHTOA. So the tangent is short TAN of theta is going to be opposite over adjacent. Well, our opposite value is b. Our adjacent value is a. So there's a really unique relationship here because we just found out that b is the same as sine, right? So tangent of theta is equal to sine of theta over a. And we know that a is our cosine. So there's a really interesting relationship there. That doesn't help us with getting onto the graph, but that's kind of the brief intro of the unit circle.